Gambardella. I'm policy officer in the Earth Observation Unit of DG DEFIS, and I will be one of the moderator of this session. I see that we're still very limited number of participants, so I will wait a few minutes to wait for the other participant to join. I see, in fact, numbers are slowly increasing. Now we're at 14 participants, so let's wait to reach a minimum critical mass to have a fruitful discussion.
Yes, please, Attilo, wait at least 5 or 10 minutes, just because it's still the coffee break, but we have launched the virtual room, so just the time that
actually we actually skipped the coffee break because Jean-François announced that this session would have started 3:45 p.m. So
okay, just maybe to
yeah, definitely. Yeah. We need to wait a bit more. Okay, I guess 1 more minute and we will start. I'm Attilio Gambardella, DG DEFIS, Earth Observation Unit. I'm joined this afternoon by my colleague Thibault Valentin and by Ola Norbeck from Norwegian Space Agency. We will be moderating the discussion session on data analytics, platforms, and value-added services. We will have a quite tight schedule. We have 8 speakers. Each of the speakers will have a slot of 6 minutes. I warmly ask the speakers to stick to the minute, because otherwise there will be very limited time for discussion afterwards. You will have control. You can have control of to change the slides, and 1 minute before the end of your time slot, you will receive an automatic notification that will warn you about your timing. This said, I see that we had 43 participants. I think we reached the critical mass to start the session. In the chat, you can read that you can swap between the two discussion sessions, and it is done quite simply through a tab in one of the in your screen. This said, again, please, the speakers, be clear and please stick to the time. The first one is Mr. Gaetano Volta from Latitude 40. Please, the floor is yours.
Good morning. I cannot see the presentation. I don't know if you are sharing or not.
Just 1 second, Mr. Volpe, please.
Okay. Okay. I have the control, or you will change the slides?
Yes, I will share it for you if it's fine for you.
Okay, perfect. Go to the first slide. I am CEO of Latitude 40, an Italian startup. We are working with satellite, and I am very happy of all the content presented before than me. Our mission is to create a urban data. Can you change the slide, because I cannot see the presentation evolving? So we are working on urban data analytics platform. That the mission of this platform is to offer a new solution to create hosted climate action plan for municipalities and urban planners. Change the slide, please, if you can. Okay. So we started from the problem that for cities it's really complex to find the data, and satellite is one of the solutions. We combine satellite imagery with artificial intelligence and just with a tool to create in very simple and effective way climate action plan and improve the quality of the life of citizens and be compliant with the COP26 and all the other mission to increase sustainability in the city. So our vision is to offer a platform with data inside to offer to comply with this mission. Change the slide, please. So we are already working with the combination of Copernicus satellite and very high resolution images. So from other providers like Airbus, Planet, Capella Space. I cannot see the slide changed. Can you change the slide, please? Yeah. So we created this data source interface so we can search and download images from different catalogs. And then we elaborate the images with our artificial intelligence and automation algorithms to create 3 products. One is the Latitude 40 climate dashboard that gives to the cities the capability to analyze the situation and define the action plans. Second one is citizen portals and ESG KPI. And the third one is really interesting because we are creating the first marketplace to sell from city side the carbon sequestration capacity to private companies. So to support the sustainability with private companies that can buy carbon sequestration capability and use these carbon credits in their ESG and marketing action. So change the slide, please. In this, one of the most important things that we did in this platform is an automatic source selection. So in our algorithm, there is some automation that can search the image based on the service that we need in the appropriate catalog. So Copernicus or commercial DHR, and we have also the capability with commercial providers to task specific acquisition. So in this case, our customer has does not need to have technical skill to use our platform. Please change the slide. So the approach beside this platform is to have a lot of building blocks. So we created, based on different capabilities, building blocks that can analyze urban islands, pollution, carbon sequestration, coastline erosion, and each city can combine these building blocks in their platform, and we offer the complete city digital twin and the capability not only to analyze the past, but using our algorithms also to identify the what-if scenario. So we can, for example, typically urban islands, we can offer a solution for this problem, identify, for example, how many trees the city need to increase the cooling capacity of the city. This one is one of the solutions. So it's a complete solution where the satellite data for us are raw materials to create actionable insights for our customers. So change the slide, please. So we offer, in this case, so we are totally downstream, and so we offer to our customer the accuracy, the total automation, the historical data, and the multi-parameter analysis. So the benefit in terms of application layer are the analysis of the environmental trends and the problem, the risk analysis and where are the priorities for action, and the definition of action plan. So how to solve the problem and how to monitor the KPIs. Last slide, how we are compliant with all the Copernicus action, because we use all the services of Copernicus, and our mission is to offer net zero by mid of the century, protect communities and natural habitats, mobilize finance, and work together to deliver a better place to live. Thank you very much.
Excellent. Thank you very much for your presentation. We will continue with the presentation, and we'll open the floor for question and discussion at the end. Next speaker is Mr. Lucas Krempel from Aurora Tech. Please, the floor is yours.
Thank you very much. So, hello and welcome everyone to my speech. Can you please go to the next slide already? So welcome everyone then to the presentation about the startup Aurora Tech and our capabilities and future plans that we have. So Aurora Tech is a pretty young startup, so we're only 3 years old, and we're based out of Munich here in Germany. And the main mission of the company is challenging the problem of wildfires, which is all over the world. In recent times, it has become more and more of a problem, and therefore I will also start then the presentation with our wildfire detection service, which we have currently, and later on I will also then talk about our thermal infrared constellation, which is coming up in the future. So could you please go to the next slide? Thank you. So in the recent years, we've seen that wildfires have become more and more of a problem, so bigger and so increasing in size and also in numbers all over the world. So destroying huge amounts of forests, croplands, endangering people and destroying property. And additionally, these fires also contribute to the climate change, as there is a lot of CO2 is being emitted. So therefore, Aurora Tech wants to do something against it, wants to challenge that problem. And therefore, we are getting active now. So in general, we are trying to get the detection of wildfires, so the time of detecting wildfires, and getting that time down to about 1 hour, and then firefighters can more easily get these fires under control. So how do we do that? Here you can see an image of the platform we have currently online. We're using satellite data, which is currently available, and we're running our own algorithms on them to detect fires. So we're using both classical and AI-based algorithms. And then the firefighting organizations or fire brigade can detect via this platform the fires and also monitor it over the time. So this data is not only available over the online interface you can see here, but it is also available via an API to do then also fire detection and also search historical fire data. Can you please go to the next slide? So in our platform, there is not only one set of data sources available, but we are merging this data with a set of different data sources. So for example, you can see there also current satellite imagery. Also there is wind information and weather information, so which is pretty important about wildfires tracking, and also humidity, wildfire risk areas, and everything else can be displayed there. As well, there are also merged ground-based platforms or ground-based data for wildfire detection. But nonetheless, so we are mainly focusing on the space data for our wildfire detection. And what we've seen during our development and also with our customers nowadays, so we have a huge problem as in the afternoon there is a very large gap of data from space usable for wildfire detection. So it's several hours, and that's also where we want to get active now. So can you please to the next slide? So we have decided to develop our own, so please the previous one. So therefore we have decided to develop our own system. You saw quickly at the slide before. Can you go please to the slide before? Yeah, there you can see our payload that we've developed right now. So that is a very small one. So it is 3-unit compatible, and it is basically a multispectral thermal infrared camera that has a very capable onboard processing. So we also want to detect fires directly in space. And then we have an inter-satellite link directly in our payload integrated, where we can get down as fast as possible then these wildfire information and also warn then firefighting agencies very quickly. Yeah, and this payload is going to fly later this year on a mission into space, and then we will have our first own satellite data and multispectral thermal infrared for our system available. Can you go please to the next slide? So, and in the future, we want to cover up. So next, yeah, that one. Thank you. Then in the future, we want to launch more and more of these payloads into space to be then a provider of high temporal resolution thermal infrared data. So with our system, we can achieve 200-meter ground sampling distance, so which is a bit coarse, multispectral thermal infrared data, and the cool thing is that we get it everywhere on the world, every hour. So that's then really high temporal resolution. So thank you very much for your attention, and yeah, I'm looking forward to your questions to the end. Thank you.
Thank you very much, Lucas. And next speaker is Giovanni Silos from X for Copernicus. Please, floor is yours.
Thank you very much for this opportunity. May I have the first slide of my presentation on, please? No, the title. Next, okay. Well, X for Copernicus is part of a much wider idea of a complex space infrastructure of cloud computing in space. This is part also of an open call for ideas from ESA, nowadays available on idea site of ESA. And is a project that we are doing as Planetech Italia with the orbit. The idea is to have a APC and artificial intelligence computing capability in orbit, in this case at service of Earth observation. Next slide, please. AX is based on Ion, that is a flexible cargo provided by the orbit. It's already flying. This cargo has a capability of about 160 kilos in IOD experiments. A small satellite can deliver up to 13 TU satellite or have on board a specific sensor for qualification. We provide through AX, that stands for Artificial Intelligence Express, an onboard processing capability of the satellite, together with a on-ground app store that completely virtualize the hardware on board. Sorry, that is not possible to see the image about the cargo, maybe because there is an animation. Please, next slide. Okay, so as I could, in some way, AX provide the best of two worlds, because provide an environment for processing at the edge, and also an environment for easy to put together in an open world space-oriented application. The process at the edge take care of the latency and network throughput, the information storage. In this way, coping on several of the requests for a shorter time of response from Earth observation system from several interested subjects. Next slide, please. So, going to the contribution, possible contribution to Copernicus, first of all, we can provide additional high-performance computing capability to other space assets, and also act as a gap filler in terms of revisit time and cooperative sensing through a constellation of Ion enhanced platform in orbit. So we can put together different set of measurements, and we can move directly space edge analytics generation. AX will also enable different scientific and commercial capability, offering possibility as also an innovation accelerator. Next slide, please. Well, all Copernicus existing service, but also future envisaged service will benefit from AX in terms of latency, resolution, in terms of ground and spatial resolution, and also to implement this already mentioned TP and Q activity in order to respond also in an integrated way, not only with other Earth observation missions, but also with the IoT on the ground of other sensors available on the ground. Next slide, please. Today, AX is under development within an incubed ESA program at PhilLab in Esrin. We will be ready to deliver the first service for Copernicus at the beginning of 2023. Since next December will be available a developer toolkits for the AX Space Store, and they will be available for initial testing from developers. So if you take contact with us, we can share this kind of information. The approach to go to market will be as a satellite or as infrastructure as a service, both to government and commercial user. We have already a lot of expression of interest from constellation operator and different other operator. And the ongoing mission on Ion Nebula is already demonstrating a prototype in orbit geoanalytics products generation. Thank you. That's all.
Thank you very much. And next speaker.
Hello, everyone.
Okay, sorry, I have, so is Mr. Entrit Metai from Aratos Group?
Yes.
Okay.
Yes, I will be replacing Mary Podogiro, as you...
Okay, I apologize, I was not aware of it.
Okay, no problem. What I will be presenting today is our service that we are providing, which is named CTLST. The purpose for the CTLST is to manage to overcome the effect, the SUI effect, the surface urban heat island. Next slide, please. The problem that we want to manage is the lack of frequent temperature measurements, the lack of accuracy measurements that we have in urban areas, and also to create the lack of green policy that nowadays is very important to overcome, especially in rural areas. Next slide. So, what we're trying to manage through the lack of those measurements and through the use of Copernicus and also the LSA and SFA measurements that we are getting, and through terrestrial models, which are add-on models into our systems, we managed to create the CTLST service. Next slide, please. Which we can manage to create high-resolution images and providing small refresh rate data. Through that need, we can design and create new green policy in order to combat the effect of the SUI that is very common nowadays to many areas in so many places that we can name of. So, next slide, please. The solution that we are providing is that through our application or service, as we may call, is to create more green policies or green areas for cities to manage to overcome the SUI effect. Also, we want to improve the quality of life of the people in many urban areas or in many domestic areas. Next slide, please. So, through green planning that we want to provide to our urban areas, we can manage that cities can create parks that can overcome the heating policies, and also to overcome the heat absorbing materials that they want to use in those areas. That is something very common that as a service, next slide please, has been used, and we can, through our application or service, some may call, to overcome all those and provide new green policy for everyone and in any place of the world. Thank you.
Thank you so much. Next speaker is José Luis Tomé from Agresta.
Thank you very much. Nice to meet you all. I'm José Luis Tomé, the CEO of Agresta, a forest cooperative. Next slide, please. And I'm here to present you Forest Map, a quick and cost-effective integrated platform for forest inventory. We were awarded with the Copernicus Master Prize in Big Data in 2018, and after that, next slide, we were funded by the SME instrument in order to develop this project. This is an amazing moment for being a forester in Europe. We are changing from a petrol-based economy to new bioeconomy. And now forest owners, forest industries needs more forest inventories. But forests are dynamic and scattered and hard to quantify. So we developed this cloud computing and remote sensing tool for forest inventory based on open science. We are using different remote sensing sources in the project, such as LIDAR, photogrammetry, but of course, satellite. And with this satellite data, we use Copernicus data, okay? And we use our field data with this kind of data in order to develop algorithms to monitor the forest. Next slide, please. We are working in several countries in Europe, trying to test the system in different forests. So we are working now in Finland, Slovenia, Germany, France, Italy, Portugal, and Spain. And we are trying to work with local stakeholders, such as forest association, special data companies, local forests, and universities to improve our system. Next slide, please. We have integrated all this in a platform where any user can select a parcel and then get information about their forest. Okay, here you have the website. Next slide, please. We already are taking advantage of some Copernicus services in land, such as high-resolution information about forests and vegetation indices. And next slide, please. We are here because we are very interested in this dialogue process to improve the Copernicus contributing missions, because this kind of high-resolution information in the future can be used to improve this system, our system, and it can be an opportunity for forest and carbon stock monitoring. And we also think that some of our products can be an opportunity for the Copernicus land service, like our system of study the forest fuel in the land. So here is our proposal. We are very interested in see what is going here. And next slide. Here you have my contact. In the last slide, is not here. You will have my contact in order to make me any question that you have. Okay, thank you very much. That's all for my part.
Thank you very much. And next speaker, Mr. Murray Kerr from Deimos. Please, floor is yours.
Okay, thank you very much. Thank you for the opportunity to present Deimos's Earth observation data activities and solutions in this context of Copernicus. So I am Murray Kerr. I'm the head of flight engineering over the Deimos group. And if you can go to the next slide, please. Deimos is, well, it's our 20th anniversary this year. So Deimos is a fairly well-established European aerospace company that offers end-to-end Earth observation mission solutions covering the complete value chain, including the satellite, ground segment, exploitation platform, and the launch. And our competencies and commercial offerings cover CubeSats and MiniSats in the range of platforms from 10 kilograms to 200 kilograms. We also offer complete ground segments through the ground segment Aureus, our product, which is employed in many current ESA Earth observation missions and in commercial missions. And in terms of data services, we offer Earth observation added value services through the Deimos Cloud exploitation platform called Services Aureus, which incorporates Deimos mission data and partner mission data. And one unique offering, which we'll focus on today from Deimos, is an integrated flight and ground processing chain and solution that exploits recent developments in edge computing and onboard AI. And this is offered through the combination of the proven ground segment Aureus and service Aureus ground products, and a new product which is called Insight Aureus, which is an onboard processing and intelligence hardware software solution. And this novel capability is included in Deimos satellites. And what we'll be showing here is that it's also offered as a standalone commercial solution, which is the focus of the next few slides. So if you can go to the next slide, please. So this next, no, wait, if you can go back, or perhaps the animation, yeah. So This first slide shows, say, the classical setup. So you can see on the right, we have the ground segment frail, which offers the FOSS, the comms, and the PDGS elements for the classical ground segment processing chain. We have user frail for the user segment, and we have service frail in the bottom center, which offers, say, the added value services mounted on top of the ground segment frail. So this is a proven suite of products that we offer, and it's functioning on many missions, including our own missions like Deimos 2 and others. If you can go to the next slide. So what we're focusing here today is a fairly new offering that we're bringing to the market, which is called Insight Frail. And this brings elements of the ground segment on board the flight segment. So in particular, autonomous flight dynamics to run the flight dynamics service on board the satellite, autonomous mission planning to replan on board the satellite, and onboard data processing, both for the PDGS and also for the exploitation platform, to run all of this on board the satellite. So next slide. So when we combine this with a geo relay service, which offers part of the Insight Frail product, we can then have a persistent and constant communication with the satellite, and all these onboard services running in an integrated manner with the ground segment services and the service frail, then allow the user, say, to tweak their flight and ground segment implementation to the needs of the mission. And the reason why we consider this to be relevant of this workshop is that this new offering offers an integrated flight ground service with new capabilities, in particular real-time services that improve timeliness, lead time, and responsiveness for on-demand services. So if you go to the next slide. So we've proven this in flat-sat testing using both SAR and optical mission data. So with our partners on the SAR side, testing using TerraSAR-X, and our partners and ourselves and partners on the optical side using Deimos 2 and other optical satellites. So why is this of interest potentially for Copernicus? Well, this integrated flight ground segment chain enables new capabilities. So we have edge computing with onboard processing, autonomous actions, so real-time optimization of the mission, orbit control, and so on. And that leads to, say, responsive and persistent Earth observation capabilities. And in particular, this improves some key requirements we touched on this morning. So in particular, related to responsiveness. So both tasking and latency we can improve. And we've proven solutions for, say, global product latency, so timeliness, to be below 1 minute for the delivery of products both from SAR and optical. And you can see on the right some of the products we can deliver, like maritime alerts and so on. So we get timeliness, so product latency below 1 minute globally. So that means we can take an acquisition anywhere globally and deliver it to the end user, the end products within 1 minute. And generally, these onboard capabilities improve throughput and efficiency of the mission with aspects like selective data transfer, which leads to improved duty cycles of the overall mission. And some of the applications to connect with what was presented this morning are clearly in on-demand applications, so emergency response, data management, security and defense. But we've also found, talking with some of the customers for this, both when this is implemented in our own satellites, or we also offer Insight Frail and the ground signal frail as an independent commercial solution, that this improves return on investment from missions. And I think we can close it there. If you go to the next slide. Here's just the contact details for Deimos, the Insight Frail commercial product. For onboard processing, you can contact me, Ground Sig Frail, Antonio Gutierrez. And then
thank you very much.
Mr. O'Carroll, you were muted for your last word.
Oh, sorry. Somehow my mic got muted, but I'm not sure if you missed me only in the last slide, but I was just saying here you have the contact details, and I believe I explained the slide before. Is that correct?
Yes, Murray, it was correct.
Okay. So yes, you have our contact details in the network session. You have Jose Gonzalez and Oscar Gonzalez if you want to contact my Deimos colleagues this afternoon. Thank you.
Great, thank you very much. Next speaker is Sei Cabrol from ET. Please, Floris.
Yes, hello. No, it's Jürgen Ackermann, as written on the chart. We have changed this morning. Thank you. I hope you get me. Next chart, please. Okay, next slide, please. So the Prométhée is a 2-year-old startup based in France, mainly in Toulouse and Paris. So we have 3 main axes we promote. So simplifying the usage of space data, really focusing on the access to non-experts based on an agnostic platform, aggregating data and easing their understanding, their usage. So offering space sovereignty with an end-to-end solution, especially also to emerging space countries, as we name them. And this is based on small satellite constellations, which are high-tech and low-cost. So the cost aspect is very important as well. And then in a later stage as well, bringing services into connected devices, working on the mass market. And more generally, we have an App Store approach for any type of applications. So it's all about high spatial resolution, Earth observation with a very high temporal resolution, thanks to a rather great number of satellites. Please, next one. So here you see the core. Next slide, please. On one hand, the space sovereignty part. So we propose a space infrastructure associated to ground reception devices, data center to manage data, and all it's around what we call our Earth Intelligence Operating System, the EIOS, which is managing the satellite on one hand, and then also streaming the data into the application side. And here it's what we spoke about before, the App Store sort of platform where you can have many various applications. Next one, please. A few words about the satellites. Yes, so we speak about a mix of hyperspectral and multispectral data, and some of the colleagues before explained very well what is about hyperspectral, and the combination of both will really open the field for much more interesting and more precise sensings. And typically, as we already had before, you can identify the organic matters, anorganic matters, so you can really specify much more what you can see besides the optical part. So this is adding a lot of value, and the resolution, the spatial resolution is more precise on the multispectral, but in the range of 1 to 1.5 meter. The hyperspectral is more in the range of 5 to 8 meters. But the combination of both will give you high resolution and with very high also spectral resolution images. Next chart, please. Here it's to show that we, beyond the data of the satellite of the constellation, we also integrate all sorts of other data. And here you can also understand that it's a collaborative approach, inclusive with other data providers. So we will not have own radar or IoT satellites, but we are working in a cooperative mode with other data providers, so that then the applications can benefit of the best and the necessary data for each type of application. And we are moving in this direction. Next one, please. So you see, next one, please. Okay, so we have the two sets of applications, one around what we call strategic intelligence, side border surveillance, illegal activity detection, but also coastal erosion, coastline monitoring, natural hazard management, and environmental intelligence more around food safety, land management, urban planning, carbon credit generation, and the biodiversity monitoring. But all these applications then are possible, and the last view graph, please, next one, you can see in which fields we have been starting to work ourselves, considering that we also in the application side have a collaborative approach and have already some partners who can deliver complementary services for our end customers. So here we have been working on land degradation neutrality, for example, around measurement and follow-up of land productivity dynamics, land cover change, carbon stocks. We have been, the green tracker is about vegetation and soil artificialization. But teleepidemiology is a very interesting study we have been doing where we can demonstrate that by satellite data and combined with other ground data and meteorological data, that we can anticipate the emergence of infectious diseases and epidemic propagation, leading to an early warning system. Then also urban climate, spotting urban heat islands, and work on urbanism to optimize this. We work on CO2 emission sequestration and carbon footprint elaboration, optimizing forest management, for example. And last topic we have been working is also urban health management. So geolocalize the concentration of microparticles and corresponding alerts. So you see a broad field and an end-to-end approach with data and services. Thank you for your attention.
Thank you a lot, Mr. Ackerman. And we have now our final speaker for this session, Guillaume Bruns from Loft Orbital Technologies. Please.
Hello, everyone. I'm Guillaume Bruns. I'm Chief of Staff at Loft Orbital. And today I'd like to talk both about Loft Orbital and our partner, Agresta. So our expertise is in space infrastructure as a service, whereas, as you'll see, Agresta is a more experienced company that's been working for more than 30 years in the data and analytics and associated services business. So if we can move to the next slide. So on the Loft Orbital side, which is presented on the left here, there are three core things we do. The first one is to fly customer payloads as a service. So it was great to have some very interesting presentations earlier, and Gerrit from ScanWorld is a wonderful example of the type of clients that we support. We typically have several payloads that we fly on board the same spacecraft, but we do fly dedicated missions as well, sometimes for demonstration purposes and increasingly for operational missions or constellations. For info, we have already sent 2 satellites to space, and you see some images. So they're called YAM-2 and YAM-3. Both were launched on board the Transporter-2 mission in June earlier this year. And to give you a sense, both of them had 5 payloads on board, and those payloads can be both for Earth observation purposes or telecommunications. Now, once we do that, typically the initial client for the payload obviously owns a certain percentage of the data, but there's typically some areas, it's either based on geography or based on a certain agreed upon duty cycle where the data actually belongs to Loft Orbital. And that opens up a number of possibilities in terms of commercializing this data directly, so both on a systematic or on-demand approach. And this is the third point, also opens the possibility of processing that data in order to provide either insights or services directly in orbit. So what is somewhat unique about Loft Orbital is our ability to serve both relatively risk-averse institutional customers. So we work with NASA, the Canadian Space Agency, the UAE Space Agency, as well as commercial actors, both large established ones, so Honeywell and Eutelsat are amongst our clients, as well as a number of startups, both in the IoT connectivity world and in the Earth observation world. So a few words about our partner, Agresta. Agresta has been working for more than 30 years. It's about 130 people today, and there are several subsidiaries that you see here, but the main three core services that they provide is, so number one, ground stations and ground segment services, mainly by Agresta. I believe the main ground station is in Grasse, in the southeast of France. Number two is they process, archive, distribute Earth observation products from all horizons, including Copernicus, and this is for any sensor, and this is done both by Agresta and Advise EO. And the third one is provide thematic services to customers, and you'll have a little bit more color on that in the next slide. And it's mostly Actus and Argans that are doing that. So on the left, so in order to, in terms of what Loft Orbital provides from an infrastructure standpoint, it's really any type of camera, and actually any payload that is currently in LEO. So under 90 kilo, this is the maximum mass of the payloads that we're able to deal with. And the current types of data that we have either in orbit or planned to be launched within the next 18 months is multispectral and hyperspectral data that we've, as well as thermal data. And all of these types of data have been very well explained by all our colleagues. We have various levels of resolution, but both medium and VHR 1 and 2. And I believe some of the payloads that are scheduled to fly are under the 4 meter that the RFI talks about. And in terms of examples of services that Agresta has experience, so you have urban and land classification. So you see some images linked to the estimation of beached macro algae, which is important for energy production. On the second one, it's aquaculture. Here the client is a Moroccan government. And last but not least, coastal erosion is also enabled by the analysis that Agresta can provide. And I'll be around if you want to discuss any of this in more detail. Thank you.
Excellent. Thank you so much. And first of all, a great thank to all the speakers for being extremely clear and be in time. Actually, you have been so clear that the number of questions is very limited. And for this, I would like to ask my colleague moderating with me the session, Ola Gramak and Thibaut Valentin, to join the screen and break the ice. We have 6 minutes left for this session. So myself, I have a few questions, but maybe Ola, you have something you would like to ask to the speakers, and or please let me know.
Yes, I have some. So you just let me know when to stop. It's
please go ahead. I think I've spoken today.
It's for Mr. Krempel. It's on this very interesting new payload that you're coming up with. Have you been in contact with the emergency management service on this? And then in that case, if not, then Attilio can probably help you. But have you heard anything from them when you're shaping, when you have a spec on your in the instrument that you are building?
Actually, so at the moment, so we are mainly focusing on forest owners and also governments to sell our service to, so that they can monitor and have a look on their forest. So if there's a fire there is detected, but so far, so with emergency agencies or where they're getting active, so we don't have so much contact there. So would be really interesting for us also getting contact in that direction. So thank you very much.
In this case, the contact is very easy. You go on Copernicus Emergency Service.
Yeah,
you can start from there. You will be surprised. It works.
Yeah, that's a really good idea. Thank you for that.
I have a general question because in my notes I have counted at least 2-3 companies that are managing or are providing payload space for a small sat or CubeSat. Which is the expected life cycle of these satellites, which in your experience or in your expectations?
That's also for me the question?
Actually, it's for there are it's you. I have at least 1, 2. I have 3. I noted at least in 3 presentations, or maybe 4. So if you want to start, but I'd like to have to get the answer from several of you, please.
Okay, then I will just quickly start off. So for the beginning, so we plan to have at least of 3 years of lifetime of our payloads in space, and but we still would like to increase that to 5 years, so to make it really economically viable. It would be for a long-term view good to have 5 years of operation in space. So that's at least for Aureus.
On loft orbital side, the 2 satellites that we have in space are ESPA class 100 kilogram buses with lifetimes of 5 years. We are currently exploring larger platforms where the lifetime would be increased to 7 to 10 years.
Yeah, from a T side, so we are starting with 50 kilogram range of 50 kilogram large nano satellites, and also expecting some things like 5 years of lifetime. That should be the first generation, and then hopefully increasing at least to 7 or a bit more.
Thank you so much. We still have a few minutes. I saw in the chat a question for Mr. Volpe from Latitude 40 about the. I saw that you already replied on the chat, but maybe if you can briefly mention that, declare that you already have customers, and out of curiosity, is this how geographically are distributed? It's one country, or it's already scattered all over Europe, please. No? I can. Okay, I don't see Mr. Volpe connected. Maybe he jumped to the other session. So very last question. I noted that in terms of platform and value-added services, it's quite constant use of artificial intelligence in many areas. One element that it's interesting to me, which I saw in some presentation, but I would like to hear more, is how this type of technology will enable the onboard analysis, or will enable and then so directly on the payload, or it's mainly for analysis once the data is collected at the ground station.
I can comment on Deimos' experience that we have it at both levels. So what we see with the customers is some applications make sense to run on ground and some on board. So we offer, say, an integrated suite where you could deploy your applications on the cloud, on the ground segment, or on the flight segment. And I think the AI normally on the flight segment, the advantage is to get accurate inferences with very little computational load. So that's the main advantage of on board. And on ground, obviously, you can be much more efficient and performing on the processing with AI.
If I can comment on this also, in some way this can have also an impact on the lifetime of the mission, because if you can process a large amount of data in orbit, you are not linked to the bottleneck of the data downloading. That is one of the limits. I agree with Marie-Claire about the fact that it depends from the application you have to do, but there are some applications that can benefit, for example, of having an IPC computer in orbit and in contact with your payload. So you can have a slimmer payload, have less weight, and concentrate on your typical mission.
On the left orbital side, we provide an edge computing environment to allow third-party, what we call massless payloads, so algorithms that would want to benefit from some of the data that we can make available. Loft Orbital doesn't do anything on the ground, but our partner Agresta has a lot of expertise on that front.
Promethe, just so edge computing is what we mainly plan to use on the satellite to reduce the data amount to be downloaded, and then artificial intelligence is more on the ground for the applications. That's the way we use it.
Yeah, so for Aurora Tech, we also use that on the satellite itself, computing directly there to just reduce the time of getting the information down, because then we can also use inter-satellite link with just small information that we can bring down. So that makes it far easier and faster getting wildfire detections done. But we are also planning to download the data afterwards to enhance our detection algorithms.
Thank you. I see there is a question on
Attilio, yeah, I just wanted to mention it to you.
Okay, we will proceed until someone will take us to the main session. For Aurora, how do you plan to implement the inter-satellite link you mentioned?
So we have
a word, of course.
I'm sorry?
In few words.
In few words. Okay, very quickly. Yeah, inter-satellite link. We're using a constellation which is already up there, and we have developed a small module which we have just attached to our payload, and we're just communicating with that. So the constellation we're using is Globalstar.
Very well. I also, apparently there is still a bit of time. I'd like to mention that with pleasure that the case of Agresta, which was supported by the instruments that we are setting in the context of Copernicus to support ideas and small and medium enterprise. And so with prize masters, and then and now all these initiatives have been embedded for the next 7 years in the larger initiatives supporting all the entire EU space landscape, which is Cassini. And my advice for some of you, which of course not for the very well established companies, is also to look at there, because there might be opportunities to help moving from ideas to concrete market opportunities.
I'm sorry, Attilio, but I don't know if you have seen my message in the chat, but it will be it was the last question, because we need to come back to the plenary session.
We were waiting for the signal, so so thank you again to all the speakers, and for again very clear and interesting presentation, and we will soon be back in the main session. Thank you again.